Hi, I'm Gabe. For this problem, we're given the system of equations and we're asked to write it as a matrix equation, ax equals b. So as we start thinking about writing the system as a matrix equation, we just want to note that A here is our coefficient matrix, so the entries of our matrix A will come from the coefficients of our equations. X is just going to be a column matrix, and since we have three variables, the entries are going to be x1, x2, and x3. And B is our constant matrix. So B is just going to have entries 9, -6, and 17. So let's write out these matrices. So as I said, our matrix A is just our coefficient matrix. So it will have the entries 1, -2, 3 in the first row, -1, 3, -1 in the second row, and 2, -5, 5 in the third row. And then our column matrix X will just contain our three variables, which in this case are x1, x2, and x3. And B is our constant matrix. So B will just be a column matrix with entries 9, -6, and 17. Now for part B of this problem, we're asked to use Gauss-Jordan elimination to solve the system. So let's begin by writing our augmented matrix. So we'll have 1, -2, 3, and 9 in the first row. We'll have -1, 3, -1, -6 in the second row, and 2, -5, 5, 17 in the third row. So here, since we're trying to do Gauss-Jordan elimination, we want to take this down into reduced row echelon form. Now let's get started by adding the first row to the second row. And we'll place this back into the second row. So what we'll have is our first row will remain exactly the same as 1, -2, 3, 9. And we're adding the first row to the second row. So in the first column, we'll have a 0. We'll have -2 plus 3, which will give us a 1. We'll have 3 minus 1, which is 2. And we'll have 9 minus 6, which is going to be 3. And our third row, nothing's changing. So our third row will leave as 2, -5, 5, 17. Now here, we want a 0 in this entry. So we'll take our third row and we'll subtract 2 times the first row. And we'll place it back into the third row. So from here, I'll come down over here. So our first 2 rows will remain exactly the same as 1, -2, 3, 9, 0, 1, 2, 3. And we're subtracting 2 times the first row from the third row. So we have 2 minus 2, which is 0. We'll have -5 plus 4, which is -1. We'll have 5 minus 6, which is -1. And we'll have 17 minus 18, which is -1. Now we want a 0 in the third row, second column. So here we can add the second row to the third row and place this in the third row. So this is going to leave our first two rows exactly the same. And here, we're just adding the second and the third row. So we'll have 0 plus 0 is 0, 1 plus negative 1 is 0, 2 plus negative 1 is 1, and 3 plus negative 1 is 2. Now at this stage, we're in echelon form, but we want to take this to reduced row echelon form since we're trying to do Gauss-Jordan elimination. So here, we'll want to clear out these three entries. So let's begin by subtracting 2 times the third row from the second row and placing it in the second row. Let me write this over here. So 2 are 3. So we'll multiply the third row by negative 2, and we'll add it to the second row and place it back into the second row. What we have is our first row remains exactly the same. 1, negative 2, 3, 9. And we're multiplying the third row by negative 2, and we're adding it to our second row. So negative 2 times 0 plus 0 is 0. Negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 2 is 0. And negative 2 times 2, which is negative 4, plus 3, is negative 1. And our third row remains exactly the same as 0, 0, 1, 2. Now what we can do here is let's try to clear out this 3 in the first row. We can do this by taking the first row, and we can subtract 3 times the third row. And we'll place this back into the first row. So where this puts us is we'll have 1 minus 3 times 0, it's still 1. Negative 2 minus 3 times 0 is still negative 2. And we have 3 minus 3 times 1 is 0. And we'll have 9 minus 6 is 3. And then our second and third rows remain exactly the same as 0, 1, 0, negative 1. And our third row is 0, 0, 1, 2. So all that's left to get our matrix into reduced row echelon form is to clear out this 2. And we can do that by adding 2 times the second row to the first row and placing this in the first row. So we'll do R1 plus 2 times the second row, and we'll place this back into the first row. So we have 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1 is 0. 0 plus 2 times 0 is 0. And then we have 3 plus 2 times negative 1 is 1. And our second and third rows remain exactly the same. So our second row is 0, 1, 0, negative 1. And our third row is 0, 0, 1, 2. Now right here, we're in reduced row echelon form, so we can go ahead and we can convert this back into a system of equations. So we can rewrite this matrix here as the system of equations x1 equals 1, x2 equals negative 1, and x3 equals 2. So the solution to the system of equations is 1, negative 1, 2. Thank you.